Hello, this is David D. Hilster. I'm a critical thinker, dissident scientist, and if you are not science woke, then this is the place for you. There are literally thousands and thousands of scientists from around the world that have been working for decades outside the mainstream who have identified problems, fixed those problems, and who are proposing new theories and models. You won't find anything like this on YouTube, so make sure you go down below and click on the subscribe button, the little bell next to it, and you'll be alerted to when our next video drops. Well, I was getting questions about, Dave, why do you talk about physicality all the time? And so I was going to talk about just physicality in general. So I said, well, I'll start with the photon. And then I read the Wikipedia on the photon. Now, if you want proof that mainstream science has no physicality for anything, well, let's start with light. This is just literally all from the Photon page from the Wikipedia. I don't have to go any further than that to show you the craziness of mainstream science. So let's take a look. Let's start out. Here's what it says. The photon is a type of elementary particle, the quantum of the electromagnetic field, including electromagnetic radiation such as light, and the force carrier for the electromagnetic force, even when static via virtual particles. The photon has zero mass and always moves at the speed of light within a vacuum. Okay, let's just look at the last sentence here. It has zero mass, but it's moving at the speed of light. So if there is no mass, then how can it move at the speed of light? You have to have something to move. Mass is that requirement. Now, if it's the case you're an ether, if you're in the modern ether theory, well, maybe you can explain that because, the photon, or at least light waves are coming at you, are just the waves through a medium. So yeah, the thing isn't moving. The waves through the medium is moving, and that sort of can be measured. So at least that non-mainstream idea would work. But the photon is an elementary particle, yet it has zero rest mass. And of course, it moves at the speed of light, which, of course, this is how you get away with this under Einstein's world, remember? Because Einstein says if you have mass and you get close to the speed of light, you'll never get there. Mass will increase to infinity, and you, of course, couldn't do that. So if it's massless, yeah, you get around. I don't know. I wish we could bring, the Vulcans or some advanced civilizations to maybe take a baseball bat and whack into the heads of physics some sanity. I won't even get into the rest of this because, let's just keep moving because there's so much stuff here. Here we go. Here's a little info box, they call these in Wikipedia, because we have our own info boxes in our Wikipedia. Check it out, wiki.naturalphilosophy.org. So its composition is it's an elementary particle, meaning there's nothing smaller than that. So there's no parts to this one. Of course, it doesn't have mass, so how can it be a particle if it has no statistics? Bosonic. How about Masonic? Yeah, guys, this is just freaky. This is freaky. Interactions, electromagnetic, weak, and gravity. That, of course, if you don't know what that means, well, gravity, the idea is Einstein says gravity bends light. Of course, then you have NASA scientists saying that that's not true. The symbol, what's that? It's a V symbol. I can't remember what that is. It's theorized, which means does that mean it's really found? We talk about it. Well, at least it's theorized by Albert Einstein. In fact, it came to head with the photoelectric effect, which of course is what he won the Nobel Prize for, which is the idea if you have a photon comes along, it can knock an electron out of orbit or something like that. Don't quote me on that, but basically that's the idea. And it's a quanta. Mass is 0. But right underneath it, you've got this less than, 1 times 10 to the minus 18th electron volts under c squared. And you got to reference that, so you can go look that up, so you can get clarified on that. So is it a zero mass? Is it not a zero mass? This smells like the neutrino, doesn't it? Which is another invented particle. mean lifetime. It's stable. Okay? Electric charge, none. Oh, well, but it's less than 1 times 10 to the 9. This is sort of like, how you buy something and it says no fat on it, but then you read it and it's got like 2% fat, but then it goes, oh, we've defined no fat as less than 2%. Spin 1. It's like a half a spin. It's like, here's my particle, and it does this, and it stops. Of course, I was told what half spin is. It's up at this part of the particle, not here. I mean, usually I just want to shoot myself in the head, but this is just laughable. Parity. -1. Okay, yeah, I got it. Yeah. And C parity is -1 as well. Oh, man, that's really interesting. Not condensed. This is just truly amazing. It's truly amazing. And you know what people say to me? Hey, Dave, the problem is just you don't understand this stuff. So what are you just to criticize? You're just here bad-mouthing it. No, we understand the real problem. Stay tuned to the end and I'll tell you the problem. Okay? It's no big deal. It's sad, the waste of human minds on this. The nerddoms. I'm a nerd, so I can say it. These nerds, they're wasting their time on this stuff. Like elementary particles, photons are currently best explained by quantum mechanics. That's the death knell. Stab me now. Just quantum mechanics is so bad. So once you hang your hat, hitch your horse to the quantum mechanics machine and exhibit wave particle duality. They can't say, well, we can't understand this, so we've invented this thing called the wave particle duality. We should solve it. No, it just exhibits it. Oh, it exhibits craziness. So here's the craziness, and here's the equation for it. For example, a single photon may be refracted by a lens and exhibit wave interference with itself. We do have explanations outside the mainstream. Our particle model explains this, but it is not one photon, not one particle. It has to be more than one particle. You can't have that. You can't have it, even logically. Oh, man. With a definite and finite measurable position or momentum, though not both at the same time. My goodness. I'm just wondering. I hope they keep this stuff around. They'll probably be too embarrassed and they'll probably nuke it. I mean, they'll probably try to get rid of this as fast as they possibly can and in all places because it's so embarrassing to mankind. Because what's this stuff? This is the Wikipedia. This is supposedly the place for the best of human knowledge. And this is sad. This is really sad. The photon's wave and quantum qualities are two observable aspects of a single phenomenon. They cannot be described by any mechanical model. There we go. It's fantasy. It's imaginable. It's in the 4th dimension. It's in the 5.5 dimension. That is amazing. They say it. I mean, it's sort of like the politicians today. They cheat you and they say it to your face. It's really amazing. So it cannot be described by any mechanical model. That is false. That is absolutely false. The particle model, our model will describe that. Ether models, depending on what it is, can also describe a lot of this. A representation of a dual property of light that assumes certain points on a wavefront to be the seat of the energy is not possible. The quanta in a light wave are not spatially localized. Now, again, I'm going to talk about what the problem with this is. It all suffers from one major problem. The standard model of particle physics, photons and other elementary particles are described as necessary consequence of physical laws having certain symmetry at every point in spacetime. This is so darn revealing. It says right here, photons and other elementary particles are described as a necessary consequence of physical laws. That is, photons exist because of the consequence of physical laws. You know what they're saying there? Let's untie this. Basically, they're saying, because we have imposed these laws upon the universe, the photons and elementary particles are described and are necessary consequences of what we have just said that the universe is based upon. Right or wrong? I'll give you one. Oh, you can't go faster than the speed of light. There you go. That's one. So basically they're saying, we humans have come up with the laws of the universe, and all these things are from those laws, even though those laws are paradoxical, even though those laws are violated by pretty much simple observations, which we have done in the mainstream. Again, remember, thousands of us find problems in mainstream science. Okay, the photon concept has led to momentous advances in experimental and theoretical physics. Oh, it has. Lots of money, that's for sure, including laser. They're lying again. Lasers were come up in the lab. No one sat around with these laws that give consequence to photons. The things that we make up as laws, which are terrible laws that are self-paradoxical, and then all of a sudden we make the laser. This sounds like when 60 Minutes interviewed the people from the Large Hadron Collider, and they asked, "What? Isn't this a lot of money for nothing?" And they go, "No, we invented the internet." He and Al Gore. No, DARPA, the Defense Department had to transfer lots of data that physicists needed. So they started DARPANET, and it wasn't a consequence of particle physics. So that would have happened with it. It would have been something else. They were just in the right place at the right time. Bose-Einstein condensation, quantum field theory, oh my God, and the probabilistic interpretation of... I tell you, I just got to go on. I can't. I'll be here all day. Physical properties. A photon is massless. This is one of the sections of photons. A photon is massless. Note 3. Watch. Got to note 3. Okay. Has no electric charge. Oh, 16. Watch 16. Okay. And is a stable particle. Okay. So it's massless and has no charge. It's not there, actually. It's like the neutrino. A photon has two possible polarizations. I'm not buying it. I can't get past that other part. In the momentum representation of the photon, which is preferred in quantum field theory. It sounds so darn important, doesn't it? Even though there's nothing to it. A photon is described by its wave vector. See, look at that. Remember what I'm saying. There is no physicality here. The photon is described by a vector. A vector is mathematical, 100%, 1,000%, a billion percent, whatever percentage you want to put in there, which determines the wavelength and its direction of proper propagation. So that means arrows, mathematical arrows, which don't really exist only in concept. Shows you where they would be, but they're not really there because they're there, but they... A photon's wave vector may not be zero and can be represented either as a spatial, spatial 3D, here, this is the good part. A photon's wave vector may not be zero and can be represented either by a spatial 3 vector or as a relativistic 4 vector. In the latter case, it belongs to the light cone pictured, and I'm going to show you that. Different signs of the 4 vector denote different circular polarizations, but in the 3 vector representation, one should account for the polarization separately. It actually is a spin quantum number. In both cases, the space of possible wave vectors is 3-dimensional. Do you understand that? Well, when you study this, and I've studied this when I was in college, these things, you get sort of the idea of what they're talking about, and you get the system they've developed. But the problem is, like I said, it's not self-consistent. It's got many problems. Let's take a look at this vector here. Now you tell me, first of all, you have, let's say this is 2 dimensions, but it isn't 2 dimensions because they obviously have these cones that are shaded. Shading is there. 2 in 2 dimensions depict 3 dimensions. So anyways, 1 dimension is time, and 1 dimension is space. Dimensions are 3, and they describe a location in space. You can't just take the things off, draw dimensions, and put, kangaroos on one side and this on another. Now, it would be different if this is a graph of something that represents some, space. This is the space, and this is the time it takes to make the space. Maybe you're an architect. How much time does it take to make so much space? Well, if I make a warehouse and there's not much to it, it's great. If I make a really small thing with lots of apartments, it's going to take longer. Then it's a symbolic thing. But this is supposedly showing physics. Physics is the universe. This is nuts. You can't have space on one line, the x-axis, and time on the other, and say this is... The cone shows possible values of a 4 vector of a photon. The time axis gives the angular frequency. Okay, so this is maybe... let's say this isn't. This is just a diagram of what's going on. But why do they do this? Why do they make it in 3 dimensions? Here's where the self-consistency gets in the way. You don't know, as a person studying this or trying to understand it, that if they're trying to talk about something really physical, or they're trying to talk something symbolic, and when you listen to them, they bounce back and forth from those 2 things, like, ping pong balls in a Chinese ping pong tournament. No offense, Chinese, just you're really good at it. It's at least that's where the best players were in the world, and maybe they still are. Can't dig myself out of that one. But let's go forward. The photon is a gauge boson for electromagnetism, and therefore all other quantum numbers of the photon, such as lepton number, baryon number, flavor quantum numbers, are 0. Also, the photon does not decay. Does not obey the Pauli exclusion principle. You get a feeling that the photon is not exactly a simple idea, and that maybe they're a little lost, and that they're all over the place. I get that idea. Experimental checks on photon mass. Well, it's not there, so current commonly accepted physical theories imply or assume the photon to be strictly massless. If the photon is not strictly massless, it would not move at the exact speed of light, c, in a vacuum. Its speed would be lower and depend on its frequency. Relativity would be unaffected by this. The so-called speed of light, c, would then not be an actual speed at which light moves, but a constant of nature, which is the upper bound of on speed that any object could theoretically attain in space-time. There's that space-time again. I'm trying to... I'm sorry. Basically, what they're saying there is, if it has mass, it goes slower, and that's okay. It didn't violate our rule that you can't go faster than the speed of light. Thus, it would still be the speed of space-time ripples, gravitational waves, and gravitons, but it would not be the speed of photons. Look at the mess here. Well, I thought gravity was the bending of space-time, and you have gravitational waves, but that's the ripples, space-time ripples, but gravitons, what are gravitons doing in there? I mean, if you're going to have space-time and space-time ripples, then how did gravitons get in there? Recent research. This is really interesting too. Much research has been devoted to the applications of photons in the field of quantum optics. Photons seem well suited to be elements of an extremely fast quantum computer, and the quantum entanglement of photons. Entanglement means you have 2 photons and they know exactly what's going on instantaneously at a distance, which Is it possible? Photons is the focus of research. Nonlinear optical processes are another active research area with the topics such as two-photon absorption, self-phase modulation and stability, and optical parametric oscillations. So basically, they're saying, the quantum optics, they're trying to use the quantum and the photon, and the quantum mechanics and optics, because, if it's optics, that's to deal with light. If that's to deal with light, that's to deal with photons. But look at what's written in yellow. However, such processes generally do not require the assumption of photons per se. They may often be modeled by treating atoms as nonlinear accelerators. Basically, what they're saying is the people probably making these machines get on their case and say, look, this has nothing to do with photons. We're treating atoms as nonlinear. What they're doing is they're making all these things that say they're using quantum mechanics for the new quantum computers. All it means is, it's really simple, folks. Computer science means today's computers use zeros and ones. You have a transistor that's on, you have a transistor that's off. What quantum computers are using is, it's not just on and off. There's a bunch of states. So instead of binary, we got more than that. And that's what they're saying. They often are modeled by treating atoms as nonlinear accelerators. And that, so nonlinear, that means there's a scale. And it's, it does not require the assumption per se. So we better put that in, because the people who are making these are screaming at us for all this theoretical mumbo jumbo. Okay, so what are the conclusions? The photon is mathematical. That's pretty much it. It's mathematical. It's got, all the same things that particle physics has, which is a bunch of packages with assumptions, as we quote from my favorite German physicist, Alexander Unziker. The photon is conceptually very confusing. I'll talk about the rest of that sentence in the last slide. And of course, a photon is not physical, therefore. And that's why we have this problem of it's massless, it goes at the speed of light, but if it has mass, it's going to have to go less than the speed of light. But it's got momentum, and of course, like when you get a sunburn, you're certainly getting something. So how could it be massless and you get a sunburn? It's like magic. Wave-particle duality is not solved in mainstream science. Yet, as the next bullet says, it has at least one solution outside of mainstream. May 2015, Bob D. Hilster has a solution to that. Light outside the mainstream has physicality, as waves in ether, or waves of particles, or movement in a lattice. And that, my folks, is the big problem. No physicality. Remember what I was supposed to do with my talk on that? Well, this is just going to be, it's going to be talks on no physicality. The photon is a perfect example of how modern science, theoretical physics, astrophysicists included Neil deGrasse Tyson, he will argue this till his death because he'd rather have his fame than be truthful. And I'll be truthful than to try to find truth as a critical thinker. Because, hey, I'm only here during this time, so I'm sure maybe he's probably not a religious guy, I don't know. And he wants to spend his time so he can make money and be famous, and he doesn't care, because once he's gone, it doesn't matter if he gets relegated to a bunch of voodoo shaman salesmen of elixirs that are promised to do stuff that do nothing at all. So I come back to my slide in my conclusion here, which is a picture of me. There I am in my gold glasses. And this is one of my favorite sayings that I've come up with. I've got my own favorite sayings. But the universe isn't complicated and paradoxical. I can't even read it. Our theories are, and this must change. And that's why you have critical thinkers like our CNPS outside the mainstream, thousands and thousands of scientists who have found the problems, fixed the problems, and who are proposing new theories and models so we don't have these problems. And that's why we are working on our own wiki. If you want to help, send me an email, david@dissidentscience.com. Remember what I always say, stay critical, stay thinking. I am Dave D. Hilster. I am a science therapist trying to get you and to keep you science woke. Ciao for now.